deductive, and reductive.
The types of deductive reasoning. Did I press the right button? So inductive reasoning was like noticing patterns and predicting the future based on that. Deductive reasoning is given this set of presuppositions. I know this is going to happen. Logic steps. That's what we use in geometry and algebra and stuff. Deductive reasoning, they classified it in 3 different types. Remember this word?
Modus.
Did you take my book?
No.
Then why is my name in it?
You thief. Did you take my book?
No.
This is
I
what.
have this friend's called it. You take it off the
No,
table
you
and
had
had my history book and Valerie's located in his backpack.
This is a bad day.
This is why we put our names in our book.
Leo.
Congrats, Mallory. Leo, you're in the doghouse. And Leo, you owe me $1.
You owe me $1.
Oh,
You owe me
And if you don't find your book, you owe me $80.
Can I enter my locker real quick?
No, you have to do it later. Okay. Okay, modus ponens was if they tell you if A then B, and they say A happened, therefore B. B is.
A then B.
This is kind of a does statement, really. So an example is if you have a cow that lives on a farm. Okay, if you have a cow that lives on a farm. You have a cow, therefore it lives on a farm.
That's your fault.
Mr. Jordan.
Okay. Yeah.
What if it lives in the woods?
Right.
So what if it lived in the woods?
Yes,
Yes, it could.
could. Steal someone's book.
That's why
It's a word.
Yes.
It's a word steal. You took 2 people.
Okay, shh. Alright guys, gotta move on. So, for modus tollens, it was kind of like the contrapositive thing. So, with my example earlier, it would be like saying, I do not have a farm, therefore I do not have a cow. Or something like that.
That's not true though.
Well, I didn't say the original statement was true, but if it was true, then this would be true also. Anyway. Does anybody remember the last one?
I do. Transitive.
Yeah, they called it the law of transitivity on this part, on the logic part. And then when we got to the geometry part, we called it the transitive property. Transitivity. So, I don't remember exactly how they said it, but something along these lines. If A equals B, B equals, not A. If B equals C, and A equals C. You've seen that so many times, I feel like you guys should know that by now. Do we got that one down in your brains?
1 second.
Problem solved.
B. Hey, could it be not B and then could it be not A then not B?
No.
Okay.
The contrapositive is the same thing. Logic is the logical equivalence of the original condition. Okay, number 25. Oh, we're starting. You guys ready?
1 second. Could you?
My assignment is in my bathroom.
I think on Runway, if I put through 54, we'll see if we can get that done. Okay, on 25 it says, state a valid conclusion for each set of premises. Premises are like your starting assumption, something you assume is true. If grandma makes cookies, we're supposed to classify the type of deductive argument, so it's going to be one of these 3. If grandma makes cookies, then the children will eat them. If the children eat the cookies, then they will not eat their supper. What can we conclude from that? And then what kind of logic would we use?
Grandma makes cookies, they will not eat their supper.
All right.
So it's transitivity.
Right, so they're all like connected. If this happens, and this happens. If this happens, and this happens. Therefore, if the first thing happens, the last thing happens. So, I bet they probably put arrows on this one. If A, then B, if B, then C, therefore if A, then C.
Do you have to write the last statement that if grandma makes cookies, then they
Yeah, you have to write the conclusion, sorry. If grandma makes cookies, then the children will not eat their supper. Transitivity. What'd you say, Leo?
Never mind.
Those are sneezes.
What?
What?
Those are not sneezes.
I'm not the only one that says it's not weird.
Just don't do your cough/sneeze. Like,
Lee, you have it too. You're like.
You have the same thing.
The cop sneeze.
Hey, at least you don't have a dad sneeze, okay?
Achoo!
What's a dad sneeze?
It's really
So
loud.
I sneeze.
Like
So,
earthquake.
you should hear my
Yeah, like
dad.
wakes you up.
Sonic boom. Are you ready?
Yes.
A lot of writing.
No, why did you?
27. If a person understands reasoning, then he, notice I said he, sorry about that, he is likely to succeed in geometry. The game was not rescheduled. I started reading the wrong line. You understand reasoning.
So,
They're using he in the generic sense. So like,
yeah.
usually I say they.
Oh, you will succeed in geometry.
Yeah, so they said, if you understand reasoning, you will succeed in geometry. You understand reasoning, you will succeed in geometry. So we need to write down, you will succeed in geometry. And yes, Lydia was right, is modus ponens.
I can never tell the difference.
Modus ponens is kind of just restating the sentence, the conditional sentence. If it has not in it, it's Tollins. I don't really have a trick to remember.
Yeah, Tollins is kind of.
You should write pollens.
It's like ponens and deductive
Yeah, I
reasoning.
think it was writing pollens on it. Yeah.
Like this is the modus ponens and Tollins thing. This is the first, like the last two books I taught didn't have those two words in it. But they did have the logic stuff in it though. All right. Anyways, state whether the reasoning. All right, I'm on 29. State whether the reasoning in each argument is. Oh no, we're skipping that. Did I write this assignment down yesterday?
You did.
I only wrote down yesterday's assignment.
So which ones are we skipping?
29 to 32. So we did 25 to 30.
Hey, that piece of paper.
Or sorry, 25 to 28. And skipping down to 36, I guess. 36 to 54. Didn't quite do everything in this chapter. Tried to cut a little bit of the fat. Number 36, state all the proper subsets of the real numbers. Okay, it's been a while since we did lesson 1. Do you guys remember the sets of numbers?
Like the rational.
Okay, let's go through the list. What was the first set that I put up here?
Natural.
Natural. And what did that include? Sometimes these are called counting.
1.
Counting
Starts at 1. Counting numbers. And then, yeah, whoever said whole. And what does that include?
0.
0,
And then? And what did that include? Yeah, I think of it like, one way you can say it is the whole numbers and all their opposites. What's the opposite of 0? 0. Opposite just means like negative, right? So it's not, if you say negative numbers, that's not right. Why is that wrong?
It's not only negatives.
positive, and also negatives could be like fractions and decimals. So anyway, da da da.
Dun, dun, dun.
Then what came? Rationals. This is the hardest group to define. If I do the technical definition, I'm probably just confused, but I'll try anyway. We'll do that. It's A over B, where A and B are, what does the Z stand for?
Whole.
Easy.
Or no,
Integers. Remember when Trey made that wacky guess?
Oh yeah.
That was stupid.
That was the one.
That was so funny.
He's trying to be funny and failed.
That's pretty smart.
Trying to find-
Anyway, this means A and B have to be the set of integers. So basically it's any integer over any other integer. But there's one example where this doesn't work.
Where?
This is one of our problems from yesterday.
Something
D cannot be 0.
Oh yeah, that one.
Because you
problem.
can't divide by 0.
That one, I find.
So that's the technical definition. So they could be, but usually I just write a list. Like they could be a normal fraction, they could be improper fractions, they could be negatives, they could be
Awesome.
integers, because you can just put these over 1. It could be a decimal, it could be a repeating decimal, but what can it? So everything up here is rational, everything. So what's not rational?
Irrational.
Pi. Never ending, non-repeating decimals like pi or square root of 7. But if I said like square root of 9, that's 3, so that would be go up here. 3 goes in all of these sets. But if they say what's the most specific set, you go up here natural. Because these sets are smaller. Even though they're infinite, they don't have as many
Things.
things. It's kind of a weird concept.
Things.
Anyway, 36. So I know this isn't even, but maybe let's do 1 or 2 of the. Oh, I said square root of 9. What are the odds?
Irrational.
Okay, 36 square root of 9 is a what? You get the direction set list all the sets that it applies to. Oh, what are the letters? What's the natural letter?
N.
Whole numbers,
W.
integers,
Z.
rational,
F. O.
Q.
Q, and
Weird
then
Q.
Q with the.
Q.
Apostrophe.
I think they.
It's pronounced
I feel like it's supposed to be
It's a
right
flying
in
column.
prime, but
I
Load.
okay, so square root of 9 is actually a 3. So what sets do 3 go in? All 4 of these. N, W, Z, and Q.
So
What are all these numbers all
Number
together? Every number on the board, what's that called?
Real numbers.
Real, and it's got a like a fancy R.
But
So
number.
do we just put fancy R for 36?
No.
Put all
36 is not all real
It's
numbers.
N.
No. Okay, it's all of them, not the most specific set. So you
Q,
have,
Z, W, N.
yes, all 4 of these. Okay.
Why do Tuesdays suck?
On B, just because you, yeah, anyway.
Oh, that's a integer.
B has 2 answers. Q and Z.
Any of the top ones on
Yeah, if it's a natural, it's all of the above. Except for irrational. Okay, number 37. Don't forget to do C and D. 37. State the property illustrated. What page were those algebra properties on? I think, is it like 80 or 79 maybe? I feel like. Yes, the force is strong with me. It's on page 78 and 79.
One with the force is.
Sam, don't get too nerdy.
I'm always.
White and nerdy.
What page did you say it was on?
78 and 79.
Oops, way too far. This stuff.
So when you multiply by 1 and the number value stays the same, what was that property called? It's on page 78. Right. Identity property of multiplication. Like it keeps the same identity, you're multiplying. Identity property of multiplication. What's the addition property, or the identity property of addition? Add 0. Okay. 37A, okay. B, it doesn't matter which order you add things in. What was that one called? Probably on page 78. Identity property of multiplication.
Congruent multiplication property of identity.
No.
Oh.
You say it wrong, just say it wrong.
Associative property of multiplication.
Let's try again. Say it again.
Associative?
Oh, no. No. Associative is when you add the first two first or the last two first with the parentheses.
Is it the commutative?
Yeah, it's commutative property of addition. Because multiplication also, you can multiply backwards. Yes, because it's adding. Okay. Sam, if you were looking at C earlier, you might actually have been right.
What?
You see, C is the associative property, but it's a multiplication or any addition. So, associative property of multiplication. And if you add opposites together, it comes out as 0. What property is that?
The
Inverse property of addition. The inverse property of multiplication is when you multiply reciprocals, like upside down. That comes out as 1. Okay, now we're in trouble because page number 38, 39.
What page is on?
Well, okay, 38 is on page
12.
12. 39 is not.
what?
I'll help you with 39. Did you guys turn to 38? No, waiting for my 39. Okay, 39, it says if segment CD is congruent to segment GH, what does that mean, by the way?
Like,
They're similar.
What does congruent mean?
same length.
They're the same. Yeah, and if they're congruent segments, they have to be the same length. Remember, if you don't put a symbol on top, that you're talking about the length of the segment from C to D, like these represent numbers. This represents things. But yeah, if segments are congruent and their lengths are the same, what's that called? How did we know this was going to be true? Because that's what congruent segments means. So it's definition of congruent segments. So if they're saying like a does statement, like because that's what it is, then the answer is probably a definition. Like if they said, I'll wait a little bit so everybody's listening. For example, if they said line A and B are parallel, then line A and B never touch. How did we know that? It's definition of parallel lines. Okay, if it sounds like common sense, it's just a definition. But we have to do this sometimes in proofs, like just kind of restate the definition. Like this is how I know this, because that's what it means. Or if they say angle A plus angle B equals 180 degrees, therefore angle A and angle B are supplementary. How do we know that? That's the definition of supplementary angles. Okay, I think you guys might remember 40 without looking it up. If you looked it up, I think it's on page 79. 41. Which three properties must be true in any equivalence relation?
What does it mean by equivalence?
Equals.
Oh.
So I think it's just asking for the properties on page 79, basically.
Reflexive,
Definition,
symmetric,
multiplication,
addition.
Yeah, they only put the first three. I don't know why they didn't put addition and multiplication. So they put reflexive, symmetric, and transitive. Equivalent means equals. So. Reflexive, symmetric, and transitive. Okay, so on this next section, more fun with algebra. Have you guys kind of noticed the pattern of these problems? There's like two different types of problems.
Hard and harder.
Like, for example, what kind of angles are those on 43? That left and the right angle, what were those called? Vertical angles. What do we know about vertical angles? They're the same. They're equal. That measurements are equal. So how am I going to set up 43? Like this equals that. Just, I don't know. I don't know why it's so hard. It causes me pain. So the left side equals the right side. But there's other problems that are like 44. What do we know about the two angles on 44? They add up to 180. So it's this thing plus this thing equals 180.
That thing.
So there's kind of been two problems that we've done every time. It's either this is equal to that, or these two add up to that, to something. So 43 is the one I'm going to help you with. 4x plus 9 equals 6x minus 7. What do we do when we have x's on both sides? Subtract the x's. Or if it was a negative x, you'd have to add it. So 9 equals 2x minus 7. Now we got a normal algebra problem, basic algebra. Plus 7, get the x by itself. You just had a revelation.
Yeah, I subtracted 7 instead of adding 7.
You know how I can know for sure that whether my answer is right?
You plug it
Plug
in.
it back in.
It works up here. 4 times 8 is 32, plus 9 is 41. 6 times 8 is 48, minus 7 is 41. It works. Okay, so A is 8. How do I find the angle GKJ?
You
Which is the right one.
the 8.
I plug it in. GKJ was basically this one, but actually both of these will come out the same, right? I kind of just plugged 8 in there. Do you remember what I got? 41. So yeah, angle GKJ is 41 degrees. Technically, we should be putting a little degree symbol on B and C. Okay, which angle, so C is find the measurement of angle FKG. Which angle is FKG? The top. They didn't give us X's for the top, so how do we find the top? Yeah, the angle that we just found and that top angle make a linear pair together, right? Like these two angles make a line together. So they have to add up 20. Any two of these angles make a straight line together. But anyway, these two have to add up to 180. So if this was 41, then this is 180 minus 41. Okay, on 45, if m is the midpoint of segment xy and xm equals 39. So on these problems, when they are talking about a picture, you need to draw a picture. If you ask me for help on 46, for example, I will say, have you drawn the picture? If you say no, I'm going to say, draw the picture. Especially when the directions say, draw the picture.
Why do you say it like that?
Because Trey didn't draw the picture.
I'm getting on the trade for this. Okay,
Why
45.
else you do it then?
If m is the midpoint of xy, so what does that picture look like?
X,
A line.
M, Y, on line.
M and xm equals 39. Where do I put 39? If xm equals 39.
Oh, that's like the first half.
Put it on the segment above M.
Put it on the segment xm. 39, that's how long it is. All right. The question is find xy, the length of xy.
So 30, oh wait, 39 plus 39 is,
Yeah, 39 times
78.
2, 78. Oh, Sam, he stole your thunder.
can't do math in my head.
You should throw your book on the floor, tip over the table,
Just leave.
slam the door behind you.
Could I?
If you want to go talk to Mr. Clown.
Yeah.
47. Right now, algebraic proof. Oh boy.
No.
Proof time, baby.
No. No.
This is the moment you've been waiting for.
No.
This is a moment you've been waiting for. Watch us all
For a
swerve.
woman like this. Okay. Statement. You guys remember how proofs look? Statement. Reason. We gotta write the whole thing ourselves.
He's like smiling as he said that.
What am I gonna put on line 1? You should know this.
The given.
Given.
What is the given?
2x plus 5 equals negative 6.
Right. What's the then x equals negative 8 part for?
For the end.
That's what we're trying to prove, right? Trying to get to. The reason is given. When we get to x equals negative 8, we are done.
Cool. So first you
Okay.
just repeat it.
Yeah. There's actually 2 things you could do besides. Does anybody know what we could do besides distributive property?
Divide by 2.
You could start by dividing by 2, but since somebody said distributive, I'm going to do that one. And what do I put for the reason? Distributive property. Prop. Then what would you guys do if you're solving this?
Minus 10.
2x equals,
Negative 11.
Negative 16.
Oh,
Addition
I should probably stop and say something.
That's subtraction.
When we do the geometry proofs on this, we usually said like 10 equals 10 reflexive property, and then we subtracted, but it was more like AB equals AB, and then we subtracted it. So just as a reminder, when we get to geometry, that's usually what comes next. When you're about to subtract something from both sides. What'd you guys say?
Addition property of equality.
Yeah. Some books call it the subtraction property of equality, but adding negatives is the same thing as subtracting.
Quality.
Oh my gosh, Leo, no.
Are you sure?
Leo.
What?
Why?
All I said was equality.
Just before something bad.
Stop, Leo.
Like,
It's racist.
It's racist. Now what?
you divide by 2.
Divide by 2.
Too late, sure. I already said it.
Yeah, if we divided by 2 to start with, I think our proof would have been one step shorter. Just realized that. Because we could have divided by 2 and then subtracted 5. And what property did we use?
Multiplication property of equality.
It's mine.
Starting to use more and more shorthand. Are we done?
One second.
Yes, we are.
I was
That's what we're trying to prove.
Yeah, but I can't see what you wrote. Quality. Only one of them?
Okay, I think those directions only apply to 47.
No.
Because 49 goes with that picture on the right.
Oh.
If the, let's see, 48. Now they wrote a proof of 48 and 49. An algebraic proof, okay. That's fine, whatever.
Mr. Jordan's disappointed. Because it was a right proof.
No, they did write, I said they did write a proof. Alright. That's kind of combining geometry and algebra. So on 49, that's what I'm doing. If angle ABC is 80, so you see the picture over there, and angle ABD is 53.
I don't need so much paper.
And, we use like 5 lines for like a 1-line problem.
You're killing trees, Mr. Jordan.
I think
You're killing trees.
You are.
You're using paper.
If I wasn't doing math, I wouldn't be killing them.
All right.
Therefore,
So we're trying to prove ABD is 53.
It's 53.
So we need to find X first. So how am I going to find X?
Thought it was gonna work.
So we've done these problems before. We never did it in proof form before, though.
Oh, the 3x plus 8 equals 2x minus 3?
Is that true? Does 3x plus 8 equal 2x minus 3?
Probably.
No, not true. Not true.
Dang.
Unless we knew what
They were even.
they were equal, or that BD was the angle bisector, then we would know that was true. But we don't know that's true. What do we know? Angle. What's the given?
ABC equals 80.
Yes. Measure of angle ABC equals 80 degrees. Oh goodness. Goodness sakes alive.
I don't think we have
This
enough
should
time.
be a 2-day assignment.
We're already
It
on-
already is a
it
2.
already
Yeah.
is
Today.
Oh.
Oh.
Okay,
Wait a minute.
so forget it's a proof for a second. If I know angle ABC, do you guys see ABC in the picture, is 80, then what can I say next?
ABD plus DBC equals 80.
Yes, or let's do the algebra version of that. 3x plus 8 plus, I guess I'll put parentheses, 2x minus 3 equals 80. I wonder if the book, no, the book said what Trey said, actually. I skipped a step, but that's okay, it's all good.
What do you do if you have been given like no numbers at all and you're trying to
Then
find?
what's the
And
reason?
you can't find it. Yeah, how do we know little angle plus little angle equals big angle? What's that called?
Angle addition.
Angle addition postulate. There's another one called segment addition postulate that you'll probably need for 48. I'm guessing 48 is probably pretty similar to this one.
You're killing me, Mr. Jordan.
All right. Now what would you do? If you're solving this, what would you do?
Put the numbers together.
Yeah, I'll put the numbers.
3x plus 2x plus 8 minus 3.
5 equals 80.
Okay, they just put simplify. I guess there's no property name for that one. What would you do? Alright,
Then subtract 5.
track 5. What property is that?
Subtract.
Addition
Addition.
property.
Yeah, it kind of depends on what book you're using, because some books do call it subtraction property. But this one doesn't. Then what would you do?
Divide by 11. Multiplication.
Was that what we're trying to prove? No, it wasn't. What we're trying to prove is angle ABD.
So then
Plug it in. So 3 times 15 plus 8 equals 53 degrees. What property did we just use? Substitution, good. When you replace something with something you know it's equal to, substitution. Substitution, that's a lot of T's. Now we're done.
Can we be done?
Hmm?
Nothing.
Nah. We'll just finish the odds and then tomorrow you can do the evens.
Do
Alright?
we have enough time to finish off?
Heck yeah.
7 minutes.
We have like 2 problems.
Yeah, we're done with the proofs pretty much.
Oh, we're going to 50. I thought we were going to 56.
Is that all I need to you?
51.
That was a joke.
Maybe I should add 55 on.
Yeah, then. But it doesn't.
So on 51, their conclusion, we did one of these before once upon a time.
Yep.
Is that angle R and angle S are congruent, because all right angles have to be congruent. So what must we have known on line 1?
R and S equal 90 degrees.
Yes, or angle R and angle S are right angles. What? Frowning at my funny face.
I should get a picture of that so bad.
And what?
You drinking.
It's kind of weird.
No. You're doing so funny. You're doing it though. You're not. You were though.
I'm just
I'm
gonna.
pretty sure I wasn't cross-eyed.
Oh, that's a awesome.
All right, number 53, segment AB bisects segment CD. What does that mean? Let's draw a picture to understand that. What's in a bisector?
It intersects in the middle.
Yeah, cuts in half. So it doesn't really say what angle it is.
So it intersects at
CD at P, so maybe it looks like that. That's called segment AB. So that might be what it looks like. Just
Are we supposed to draw a picture?
No.
Okay. Not on this one.
Yeah, we haven't done one of these before. Exactly. We talked about a bisector, but we haven't really done the roof line. If I know that's true, if AB is bisecting CD, then what do I know?
P is in the
P is the
midpoint of
center.
CD.
That's right. P is, it has to be in the middle. So P is the midpoint of CD. P is midpoint of CD, segment CD. And then the next line on the proof would probably be what? If P is in the middle, then what do we know? If P is the midpoint, then
The mid.
CB equals PD. That's the definition of midpoint. But we don't have to keep going, we just do this one. I'm just telling you, that's how it goes. See, you got 5 minutes, Sam.
Do I want to use those 5 minutes wisely?
No.
We're just not doing.
You don't want to, but you will.
No.